Cisco CCNA 7, Chapter 7, Packet Tracer, 7.2.10, setting up DHCP. So here's our network, and we've got routers 1, 2 and 3, connection to the internet, we've got a DNS server, and we're going to try and get DHCP down onto our 2 LAN segments. And we're also going to be a client because one of these devices is going to DHCP to this router. So if we go to our config, got basic IPs set up. Well, let's go and see what they want us to do. We're on router 2 and we want to put in our excluded address. An excluded address for us is in our 10 network from 1 to 10. So in here, we've got our 254 device IPs we can hand out, but we're going to reserve 10 of them. Now, one of those is going to be the default gateway. So the syntax we need to put in IP for IPv4, DHCP excluded address, our gateway address, and because we've got a range, we can capture those between the .1 and the .10. Now, interestingly, that's done in a global mode. If we go to the next command, IP DHCP pool, one LAN, no spaces, we're now into a DHCP mode. That's a little bit confusing when you first start. Well, you exclude your addresses first, then you make your pool. You do that because if you make your pool and apply it, you can actually hand out an address that you don't want to. And we don't want to hand out our gateway address to a computer. So that's why this is outside the pool. Well, what are our options in here? We've got our default router, DNS, domain, exit, network, no an option. So what do we want to start with? We're going to put our network in because that's going to define how many IPs we're going to hand out. So if we type network in, basically we're doing that. And that is the network that we're going to use. These will be the hosts. Obviously, they're the IPs that will be handed out. And this hasn't been subnetted out. Obviously, if it's subnetted, it will work the same normal way subnetting does with networks and hosts based off the mask. If we type in default router, what does that mean? Well, the default router is saying for this pool, hand out these addresses, and it really means go out this interface to do it. Because it doesn't know which way the pool wants to push. It can push out here, there, or if it was on, sorry, it was here, can push out in those 4 directions. So we want to push it out down here to this gateway address here. The DNS server is usually handed out by DHCP because as you get your IP, you become active on the network. Well, if you want to go and find URLs like cisco.com and you don't have a DNS, you've got to start going through the DNS process. If it's bound in your DHCP information and you know where the DNS server is, it makes it easy for the DNS lookups to occur. So then you can go out to the internet and find your URLs. So that's usually typically linked as a binding. So that's all the information we need. Now let's get out of that pool They want us to do the same thing for our R3 LAN, which is down here, but they don't give us any information, so we've got to go and work that out. So we know this is a 30 as the network. We can assume the DNS server is the same. We can assume that it's 30.1 as the default, and we can assume that they're going to exclude the first 10 addresses. So let's go and type all this information in, and our information we want to send this out on is on this gig here. So we're going to put our excluded addresses in. We're going to go and make our pool. Now we want to go and set up our network. I want to set up our default router. 30.1. We want to set our DNS server up as well. Now they're all set up. Let's have a look at them. Here's our excluded addresses for our 10 and our 30. Here's our first pool, the addresses it's going to hand out, where it's going to get the addresses from. And then we've got our pool, the addresses, the routers, the default gateway, and we've got our DNS server. Now that's set up on this router, but this router is not directly connected to the LAN. It's got a link between it. So when this request comes up, this router has to have knowledge of what the request is for and where to send it. So that's typically known as an IP helper address. So we're going to put an IP helper address on here that points up to the router that's got the pools on it. And that's explained in here. So we're going to put on our R1 for our LAN interface gig 0, and we're going to put a helper address. Now, how do we know what this address is? 10.1.1.2. Let's go on to this device here. And we've got on our serial 0, which is attached, 10.1.1.1. So we can assume that this is the address that is handing out the IPs for this LAN segment. So let's go and put this on. First thing we do is we go onto the interface. When you get tested, always be asked where the helper address goes. It goes on the client side of who's requesting, and then the router makes the choice of where to go because it knows where the information is for the helper address to route to. IP, IPv4 helper address. Now it can't be .1 because that's just going to set it here. It's got to set it to where the IPs are being handed out. The IPs have been handed out from that router. Well, let's go and see if this works. I'm on my computer. I would ask for DHCP. and I get 11. Now, why do I get 11? Because the excluded range from 1 to 10, so this is the first address after that. So if I was to type in www.cisco here, the DNS would come into play as well. Now, if you do go DHCP and you don't get the address you want, don't be fooled when you get an address. There will be an address that will populate in here if you can't find a DHCP server, and that's a 169.254 address. And quite often, many clients ring up help desks, and the person on the help desk will say, "Do you have an IP?" And the client will go in and say, "Yes, I do," but they won't tell them what it is. And the help desk person assumes that it's the right IP. So if you ever see a 169.254, this here cannot find where DHCP is coming from. So why self-assign? Well, that means if you have other devices as well on here, they can still talk to each other while they're fixing up the DHCP. So you can still print, log onto your servers, etc., make phone calls, if it's all within the LAN segment. Let's go and do the same thing up here. Well, first of all, we won't do that. Let's see if we can get an address. And yes, I did. But no, I didn't. So that's what we were talking about before. We got a 169.254. So why did it fail? Well, this device doesn't know where to get the IPs from DHCP. So it can't ask. It has no knowledge of it. So we have to help it. Well, how do we know what that address is? Without the port labels on here, we can assume that our S001 is 2.2.2.1. We can assume the other end is 2.2.2.2. Let's ping it just to make sure. Oops. That's the wrong address. And we want to ping 10.2.2.2. And I do get success. And it's only a serial link, so that means that has to be that address. You can send out a ping flood and you get a reply as well. So let's config this up. Is it a 00 interface that's set up? Yes, it is. Is our 30. And now we want to help it. So IP helper address 10.2.2.2. And where we failed before, do we have success? Yes, we do, 3011. The next part is we want to set up our router 2 as a client. So we're going to say you are going to turn into and ask for an address on your interface. And this one, which is your ISP typically, will hand that out. So this is on the interface itself. So for us, that is going to be a gig 01 IP address. We can either put one on there or we can ask for one. That's what we need to do. Now, we have to obviously bring that interface up. And then we can end. Then we can work out what address we get. Well, how can we work out what address we get? If we go show IP DHCP, we want to look at an address we get, we're going to look at the bindings. The binding means it's been handed out. So there are the addresses for the 10 and the 30. And if we go show faces gig 0/1. We are connected and we are up. So we're finished. We've got our IP, which has come through here. Here we go. DHCP is 209.165.200.231 from our 209 server.